Welcome back, friends. Let's look into a couple of real life problems on the velocity time graph and the displacement time graph, and then the acceleration time graphs also. So what happens if there is a car? What happens in real life that if this car is moving, let's say it started from the rest condition. You start from your home, let's say 0 meters per second initially at rest condition. Slowly but surely it start moving in the forward direction, and over a period of 10 seconds, after 10 seconds the velocity changes to 30 meters per second. 30 meters per second, and that's more of a real life scenario. And then if you reach on the highway, you keep on moving with 30 meters per second, and this is 30 meters per second with the constant velocity. And what I wanted to do is I wanted to draw the displacement time graph for this scenario. Then I wanted to draw the velocity time graph for this scenario, and after that I wanted to draw the acceleration time graph, acceleration time graph for this scenario. Now let's look into how this will look on the displacement time graph. So what do you observe? So initially the velocity was 0, and then after 10 seconds the velocity changed to 30 meters per second. And let's draw displacement time. So what's happening in this case is that you started from 0 slowly, but for first second do you let's suppose the velocity changed from 0 to 2 meters per second in the very first second. So it means you covered certain distance at a slower speed compared to when you were at 10 seconds. So in the next second the velocity changed to 5 meters per second in this second. So now, because you were already moving with 2 meters per second, and now your velocity is after second the velocity is 5 meters, so you're gonna cover more distance compared to whatever distance you covered in the very first second. Then that happens in the real life scenario. As you speed up, you end up covering more distance compared to the previous distance you covered in the last second. So the graph, if I draw the displacement time graph, we started from 0 0. In the very first second we covered small amount of displacement, and then it took us 1 second to cover this much displacement. The displacement was very less. Let me change the color. So the displacement was very less because the car was initially very slow, but then as the car picked up the speed, in the lesser amount of a time you covered more distance, isn't it? Or shall I say displacement. And that kept on happening for the first 10 seconds. So that's how the graph will look like for the displacement time graph for first 10 seconds. The time taken to cover, see here, the time taken to cover this displacement, this was the time taken to cover, this much time taken to cover only this much amount of displacement from here to here. That was the time. But over here, if I look into this section, I covered, let's say this is 5 seconds, and this is from 5 to 10. So from 5 to 10, the time was, again, the time difference is 5 seconds, but the displacement covered is way more compared to first 4 seconds, isn't it? So that's how the displacement time graph will look like for the real life scenario when the car is accelerating from 0 to 30, or it can be any other value. Then after that it is moving, after 10 seconds it's moving at 30 meters per second for the rest of the journey. So how the graph will look like, because it is covering equal amount of distance in equal amount of time, because it's not accelerating now, it's moving at a certain speed. So the graph will look like a straight line, or shall I say a slant line. This I'll call a slant line. So that's how the graph will look like for this scenario, the displacement time graph. Now if I wanted to draw the velocity time graph for the same situation, how can I draw the velocity time graph? So let's look into velocity time graph. So initially the velocity was 0 meters per second, and then the velocity changed to 30 meters per second after 10 seconds. So as the time is increasing, the velocity is also increasing. So what kind of a graph I will come up with? time is increasing, velocity is increasing, so it will be a slant line like this for the first 10 seconds. And once the first 10 seconds are over, the velocity does not change. It's 30 meters per second. It stays 30 meters per second for the rest of the journey. So what kind of a graph I'll draw? I will draw a straight line. And one thing I forgot to say, everything is in the east direction, or the body is moving, the car is moving in the east direction. We don't want it to confuse ourselves with the signs right now, because we are learning the basics of the graphs. So this is how the graph will look like for velocity time. And then now I wanted to draw this situation for on the acceleration time graph also. So how does the acceleration time graph will look like for this situation? So this is acceleration on the y-axis and the time on the x-axis, and let's draw it then. So I will like you guys to pause the video and try and draw the acceleration time graph, because that's very simple, and then try and match with my work and see what's happening. If I wanted to find the acceleration value will be equal to final velocity minus initial velocity divided by time. So that will be 30 minus 0 divided by 10. That's 3 meters per second. So that's and in every second the car has the velocity has changed by 3 meters per second. So acceleration in every second is changing 3 meters, 3 meters per second the velocity is. So now velocity changed by 3 meters per second, 3 meters per second. So the acceleration for first 10 seconds value will be equal to 3 meters per second, and it will be a straight line because that's an average acceleration. And after that, once the car is moving with 30 meters per second, and here the car is moving with 30 meters per second, again we can apply the mathematical formula, and I'm sure you might have guessed it by now. So the acceleration for that scenario will be, it will be 0. So it will come down and it will be 0. This is the 0 acceleration, so that's why I'm drawing a horizontal line with the x-axis. So that's how the acceleration time graph will look like for this situation. Now this was one of the situation. Let's try and draw another situation. So let's say the car is moving at 30 meters per second. This is 30 meters per second, and then you are about to reach home. Again, you are moving in the east direction, or you are about to reach to your office. So you will naturally slow down your car. So if you slow down your car, it will come down to 0 meters per second. Let's say again the time interval was 10 seconds to slow down your car. I'm taking these numbers so just to make my calculations easy, because I don't have the calculator with me, so I'm just taking the simpler numbers. I wanted to draw this situation on the displacement time graph and acceleration time graph and the velocity time graphs. So let's dive into it. So let's draw the displacement time graph first of all. Again, everything is moving in the east direction. So this is east, and car was moving at 30 meters per second. So if the car is moving at 30 meters per second, and then for the very first second, let's say it changed from 30 to 27 meters per second. So it's still fast, and then over a period of time it slow down. So initially, in a given amount of time, it will cover more distance, and then as the time will elapse, it will cover lesser and lesser of a distance. So the graph will look like this curve. See here, if I try to find this area, so here, see, let's say this is 2 seconds. In the first 2 seconds, the displacement covered was this much in the east direction, and then in the next 2 seconds, the displacement covered is way less, isn't it? This displacement is very less as compared to the previous one. So that's how the displacement time graph will look like for this real life scenario. Now I wanted to draw the velocity time graph for this. So if I look for velocity time graph, Now velocity time graph. So how does the velocity time graph will look like this? I will like you guys to pause the video and try and draw it by yourself, and then come back and match your answer. So initially the velocity was high in the east direction. So this is the initial velocity, 30 meters per second. Because this is a positive, so I'll draw it in the positive direction. These are positive values of velocities. And then over up here, it's slowing down as the time is elapsed. As we are consuming the time, it's slowing down from 30 to 0. It's coming down to 0. And here it will be 0 meters per second. So that's how the velocity time graph will look like for this situation. And now I wanted to draw it on the acceleration time graph. Acceleration time graph. And the velocity change from 30 to 0. So final is 0 and initial was 30. So this value will be final. So 0 minus 30, and then this will be time elapsed is 10 seconds. So the value will be negative 3 meters per second. So if this is negative, so acceleration graph will be drawn on the other side. So this will be the acceleration. Again, this is an average acceleration. So the graph will look like this, because this value comes out to be negative, and that's also understandable. Think about this: if the car is trying to stop, why the car's gonna stop? If when you apply the brakes, the car was moving in this forward direction, you applied the brakes, what car is doing? Imagine there is no car, imagine there are no brakes, and someone is standing in front and trying to stop this car. So other person has to apply the force in the opposite direction, and that's what we got on the graph also. That's why the value is negative. So the acceleration is in the west direction, although the car was moving in the east direction, but acceleration is in the opposite direction when you apply the brakes. So hopefully you were able to understand some real life situations. I'll make another video on some more real life situations. So I'll see you then. Bye now.